Hello and welcome to Data Management. This is Module 1, Part 3. In this segment of Module 1, we'll spend some time discussing database tables. We'll introduce some terminology for databases such as entity and attribute, primary key or identifier. We'll also provide a very quick introduction to SQL, MySQL, and MySQL Workbench. So let's get started. Okay, in terms of databases, as we mentioned before, a relational database management system, you have data stored in a series of tables. Keep in mind that the table is designed to store information about something. So what kinds of things do we want to keep track in our database? And how do we build our database tables around these things? Well, the answer is what we refer to as an entity. An entity is just something that we want to keep track of. Again, an entity might be something like a customer, or a product, or an order. In terms of our data modeling, which we'll be spending more time on later, we can represent an entity by a rectangle or a square. So in this example, we've got an entity called share, which would be possibly a share issued by a publicly traded company. An attribute is a fact about an entity, or it's a data element that describes an entity. So if we had a customer entity, for example, we might have attributes such as customer name, customer address, customer phone number, and so on. In this instance, or in this case, with our share entity, we've identified attributes of share code, share name, price, quantity, dividend, and price-earnings ratio. The attribute names that we use within our entity should be unique within our entire data model, which means later on when we start talking about more complex databases, we might have a data model or a database that contains data on maybe 10 or 20 or 100 entities. And we want to make sure that the names we have, the attribute names we have, are unique across all of those entities or all of those tables. So for example, we might have something like a customer name and customer address in our customer table. We might also have a supplier name and a supplier address in our supplier table. Well, we want to make sure that we use customer name and customer address, or supplier name and supplier address, rather than just using address, because that way we won't have any confusion over which address we're talking about. Is it a customer address or a supplier address? In addition to the attribute name should be something meaningful. So when someone else looks at our attribute name, it should be relatively easy for them to figure out what we're talking about. Every instance of an entity must be uniquely identified. So by that we mean, for example, in a customer table, we want to make sure that we can distinguish between two customers. So if we have a common customer name like John Smith, and we have multiple people with the name John Smith in our customer database, well, we want to make sure we can identify which John Smith we're talking about. So that's why we need some type of unique identifier. And typically something like a name is not unique and would probably not be the unique identifier. So in this instance, or in this case, for our share entity, we're using share code as a primary key or identifier. And what that means is we're going to have a unique code for every share in our table. If, as I mentioned before, we don't have an obvious attribute that's unique, so if we have customer name, for example, and that's not unique, we can create one, something like customer ID or customer number, or in this case, share code. It's typical to denote an identifier or a primary key by using a leading asterisk, such as we've done here with share code. So some rules for creating a table. Once we've defined or identified what our entities are, each entity becomes a table. The entity name becomes the table name. Each attribute becomes a column. The identifier is equivalent to a primary key and is used as a primary key. And then each row in the table is one instance of the entity. So here's the one we looked at before with our share entity. And in a table form, you can see we've got share code, share firm, share price, share quantity, share dividend, and share PE. And you'll notice that the share names or the names of the attributes in the table do not match directly with those. In the entity, don't be too concerned about that. That's just for ease of writing, ease of use. And these are consistent with the names that were provided for the table that you'll be using for some exercises in Module 2. So I wanted to introduce you to those now. But regardless of that, you can see that we've got the same share name. Regardless of that, you can see that each of the attributes is represented by a single column, and then each instance of our share is represented by a single row. So for example, Abyssinian Ruby with the share code AR is listed in one row in our table. So that's one instance of the share. So let's try another one. So we've got a ship, which has a name, registration code, gross tonnage, and a year of construction. Also, ships can be classified as either cargo or passenger. So, take a minute, pause this, and draw a model for keeping track of ships. Okay, so here's a sample solution to that request. We've got ship as the name of the entity with a registration code, ship name, gross tonnage, construction year, and ship type. And then the ship type in our table would actually be represented by either a cargo ship or a passenger ship. So let's talk briefly again about the role of the database management system, which we introduced earlier in Module 1. Visually, you can see that the database management system, again, is a software package, and it's used to store, create, process, administer. Basically, it becomes a traffic hub. So with applications such as an enterprise resource planning system like SAP is interacting with a database that does so through the database management system. So the DBMS is the software that captures the data from the application, stores it in a database, and then retrieves it when needed. You can see we've got SQL listed here. We'll expand on the role of SQL later, but for now just look at SQL as a method of retrieving and storing data, retrieving data from a database and storing data into a database. So the database management system, again, is just software that maintains databases. It's able to handle complex situations, so we can have multiple users at the same time, so concurrently entering and retrieving data from the database, and they can typically handle very large data sets. Once you create a database using one type of database management system, you typically can't easily port it or use it with a different database management system. So if you create a database using MySQL, for example, you can't directly interact with it using Microsoft SQL Server. However, you can have some integration between them using standards such as SQL, which we'll expand on later. So again, the database management system, it's a way of keeping related data and storing it in an efficient and compact manner. So it's efficient in the sense that it's able to be accessed very quickly. It's compact in the sense that we try to store the data in as little storage space as necessary, and the database management system handles that. And then the related data part is that the data that's stored in a specific database is typically about some particular topic. So we might have a customer database or a marketing database or whatever it might be. We've got quite a few different database products, and the ones listed here are all relational database management systems. So we've got Oracle, SQL Server, which is a Microsoft product, MySQL, DB2, which is the IBM product, and so on. The application layer is what runs on top of the database management system. And those are applications that allow organizations or individuals to perform certain functions. So as we mentioned, the Enterprise Resource Planning application, one example might be SAP, another example might be Oracle. These are applications that have been written to look after specific business functions like human resource management functions or inventory control. Those applications interact with the database management system, and they use SQL to do so. So what is SQL? Well, it's a language. It's a database language. It's not considered to be a complete programming language. So if you're familiar with languages like R or Python, you can do a lot with those languages. They're very versatile. You can program them to do just about anything. SQL or SQL is not as versatile. It's powerful, it's efficient in many ways, but it isn't as versatile as a complete programming language. And as we get into learning more about SQL, more about SQL, we'll explain further what that means. But SQL allows you to define your database, to store data, and to manipulate it. And when you hear the term SQL, make sure you distinguish it from popular database names. So MySQL, Microsoft SQL Server, those are not the same things. They're not the same as SQL, the SQL language. So let's take a look at this and think in terms of what was installed on your computer, what you're going to be using for this course. Well, here's a map of what it looks like. We've installed WAMP server, which has MySQL as one component. MySQL is the database management system that we're going to be using to store and retrieve data from a database. The application you're going to be working with is MySQL Workbench. And MySQL Workbench was just designed to make it easier for you to work with MySQL. It uses SQL programming language as it interacts with MySQL. So, just a few takeaways from this part of the module. The database is designed for storing and retrieving data, keeping track of something. A database is not a spreadsheet. So again, a database allows you to maintain relationships as well as data. We learned some components of a database. So each database contains some number of entities. Each entity is described by a certain number of attributes and so on. In terms of the big picture architecture, the database management system is the software that stores and retrieves data from a database. Applications are built to interact with the database through the database management system. And we learned a little bit about creating a table, or at least defining one in terms of the name of the table and the attributes that would be considered with it. One final note before we end this segment. I've been asking you to complete a number of SQL assignments. They are designed to build up your skill set in terms of programming with SQL and to prepare you for the SQL project, which will be required later in the course. I will be grading your assignments on effort as well as outcomes. So by that I mean please do not leave any questions blank. If you don't have something there, I can't provide partial grades. We'll be using the Canvas assignment interface for me to distribute the assignments and for you to submit your solutions. I will not accept late assignments because we'll be posting answer keys. And so obviously I can't have you complete the assignment after the key has been posted. And I've given some suggestions on how to label your screenshots and your code so that it's easy for me to understand which question you're answering, what your solution is, and what the response was that you obtained from MySQL. That is the end of Screen Capture 3 and the end of database management. That is the end of Data Management, Module 1, Part 3.